So I think I'll start, like I said, from where I think we left off, and apologies if I mean, call out if I'm covering stuff that we've already covered. So I think if memory serves, I think we were talking, so we'd started kind of mutating joins towards the end, if I remember correctly. We talked about by. We sort of talked about how there's this new join by function that is kind of an alternative, or like at least at this stage we can consider an alternative to, whoops, sorry. Turn that off so we don't get so we don't get bothered by chat. Like an alternative to kind of like the typical specification that we normally have. I think, unless Jack, you happen to know what this is, we were kind of puzzled what copy meant in terms of the specification. Let me.
I remember thinking, I don't know what that is.
Yeah, I mean the what do you call it? The documentation was pretty Spartan, pretty terse. So let's see. Sorry for the very fast scrolling. Yeah, so copy. If X and Y are not from the same data source and copy is true, then Y will be copied into the same source as X. This will allow you to join across tables, join tables across sources, but it is potentially expensive operation, so you must opt into it. Our best guess, I think, was Rebecca's guess that this has to do with databases, since I guess the tell for her was
SRC.
SRC, exactly.
Which I thought was source, and Google. I'm not totally sure that I maintain that statement, but I did ask Slack, and Gus did a little bit of digging. I didn't ask specifically about copy, and I asked for the definition of SRC, which he didn't know from experience, but he did the, diving of like, well, what is it a class of?
Yeah.
And that kind of confirmed it, but it didn't solidify totally in my head. But somewhere in, I think, general, there's a question I asked for. He does some diving.
Yeah, so I mean, I guess it still kind of remains a question mark, but I think we're maybe zeroing in on it. So we talked about the suffixes, I believe, is a method where you can disambiguate where columns come from when columns have the same name in the two tables, X and Y. So the default is this .x and .y. You can specify your own. Keep, I think we talked about. I feel like we didn't talk about NA matches. Does that sound right?
I left like a smidge before you guys ended and haven't watched the video, so it was not covered before 10.
Okay, all right. So I think after that, we pretty much just kind of said, where do we go next, or what else do we have to do, I think. Does that sound right, Shah?
Yeah, I think so. That's good.
Okay, all right. So I guess we'll start up here. So I'll just create two data frames. I've created, a data frame earlier that you can kind of see here. So just two columns, C and B, 1, 2, 3, 3, 2, 1. And then another table with column A and column C. And so the question here becomes what to do when you're joining two tables and your key has an NA, right? And I think the default behavior is to match on NAs. So here we have, I guess maybe to look at the original data sets, we have, whoops, that didn't work out. DF1 with NA. Oh, sorry, I need a number there.
Just as like a conceptual thing before like we see the code and how it works and stuff, is the idea kind of like when you left join, you expect to get, well, if there's not duplicate matches, like the same number of rows as your data frame, like that you're putting in.
I think that's one consideration, certainly, Jack. But I mean, I think another is just in this specific case, like maybe narrower case, is what to do with NA.
Yeah, but so what I mean, sorry, is like, say if you had rows that were NA,
yeah,
and you didn't join on them, like you filtered them out or whatever, you wouldn't be returning the same number of rows, or why, what's the reason that this exists kind of thing?
Yeah. I mean, I guess one, at least to my mind, would be, not joining things that shouldn't be joined. So if you're missing a key, you kind of, I guess as an analyst, you need to say what to do with things where keys are missing. And then I guess you have some freedom with the NA matches. Let me actually just pull up the documentation here. I'll just take left join. Oh, that helps. Sorry, I like this terminal in VS Code, but sometimes it can be a little slow. It's going through Python. And naturally it doesn't find. Okay, let's just do what I've already got it pulled up. NA matches. Here we are. So I guess you have a few values here. Should NAs match? So the default is that two NAs are considered equal and would match. And then the alternative is you never match NAs. So in that case, if you don't match NAs, then your table size, depending on your merge, your table size wouldn't change. So kind of if you look at these two tables, we've got one where I've got an NA in A and I've got B equals 4. Here I have an NA and C equals 8. So if I elect not to join on where the value is NA, then here I'm doing a left join, right? So I have a left join, so I still have the same size as my left, as my X, as my left hand. Wait, is that correct? Okay, well, not same size in this instance because there's a little bit of a one-to-many matching here. But in effect, like I still have this observation. I haven't lost that observation, kind of to your point, Jack. So I'm not losing information in the join process if I'm doing a left or a right join or something like that. It's just a matter of, but notice here for column C, I'm not bringing over any information from my table Y.
I am so glad that you called this out because this is unintuitive to me. I think of further default behavior because I think of NAs and R as being, right, I don't remember exactly where this shows up explicitly, but that meaning that it can be any value, right? Right, like conceptually an NA.
Yeah, it's like I guess they say it's like NA is like not available, so it's just missing. Yeah.
So the idea that it could that you would confidently default behavior be matching and saying this NA, which could be in the space of real numbers, and this NA, which could be anything else in the space of real numbers, are the same thing. That your behavior with never is what I would kind of assume. Like, let's keep all of our left data. This is a left join, but let's not assume that we know anything about our right data.
I'm with you, Rebecca. I would prefer to have this as the default. That's what you're saying, right?
Yep. Yeah.
Okay.
Yeah, it makes sense. So I'm very, very glad that you looked at these arguments because I would. I normally think the defaults are, aligned with
sensible.
my understanding of how things should be. So thank you for this.
I mean, I guess the surprises might come if you did an inner join. So I guess left and right are kind of clear. Inner join, you might end up in this case that Jack is talking about, although I guess for inner join, it maybe wouldn't be so surprising, is that you could have your columns with, You could think that you're merging together two things and you have keys that are missing in both tables, and maybe somehow you would expect that they would join on those keys where NA is a value and you're just joining on those missing values. But you could end up with like an unexpected number of rows, right? Or unexpectedly fewer rows for those particular cases. But still, I mean, for me personally, I would prefer this to be the default. Now that I know that this is the default, I think I may be using this more often. Yeah.
I have a confusion about this. If you say NA matches never, then it should delete that row, or what is it doing actually?
So this one right here, Shah. So this is basically this row is coming from our it's coming from this table. So,
Yeah,
and we have a left join. So basically we're like taking this as the table X, and then we're joining table Y on A.
yeah,
And so with the left, like in this particular case, because it's a left join, we're basically we're keeping, it's sort of like we're keeping this table and then we're adding to it values from table Y, or yeah, from table Y. And in this
okay.
case, we're not bringing over any value from table Y because we're saying we don't want to match on keys when keys are missing.
Okay. So if we say NA matches, then it ignores that NA in the other table. Okay.
Yeah. So I mean,
Yeah.
if we did an inner join here, okay, then that observation's gone.
Yeah. Okay, it makes sense. Yeah, okay. Thank you.
Yeah, no worries. This is another thing I thought was really nice. And well, kind of nice in a certain sense. Maybe I'll come to this later. But you know, when there are cases where you're joining on when you're joining on two tables right here. So I'm doing a left join with data frame 1 and data frame 2. Yeah, let me, sorry, just to set the scene here. We'll do data frame 1, data frame 2, and then I guess let me repeat the join right here. So when we have, notice when we have value 1 right here and value 1 right here, right? So notice what happens is we have in our table X, we have 3 rows, and our table Y we have 4 rows. And if we do left join right here, then we end up with 4 rows, because basically for this key equaling A equals 1, we're matching this row with 2 rows right here. So you can see we kind of like expand the table to in a certain sense. And so we end up with 4 rows. So that's what happens when, you know, A equals 1. So by default, I guess here like the argument is multiple. So we're not specifying the argument, but by default, you know, we have an argument that allows us to say how we want to handle cases where there are multiple values of the same key. And by default, we take them all. So the default is the value all. So if I were to kind of restate the same thing and I'll just add multiple equals all, I get the exact same result. So that's the default behavior in dplyr. And so there are other basically values you can have here. So you can have any first. So you can say like, okay, in the case where there are multiple candidates to join only on the first detected, on the last detected, and maybe, let's see, sorry, I haven't looked at this recently, so it's not fresh in my head. No, okay, so these are the only 4 values, all, any, first, and last. So maybe let's come back to any, last. So in this case, if you recall, I've got data frame 1, data frame 2, and so here I have 2, again, for A, I have two cases where the key equals 1, right? When I'm joining. So if I wanted to, I could do this where I could only take the first and Y, in which case you'll notice here that I'm only selecting, so df2 be this one right here, right? So when 1, I have the value 4 right here from this first one. So I'm not bringing over this row. Alternatively, I could do the last. Oops, sorry. I could do the last. And here, coming back to this df2, if I took the last, then I should find 5. And indeed I do, where the a equals 1.
So is that,
yeah.
Well, Garth, can I, on this one, I guess this is maybe one of you guys are going to have more knowledge about this kind of stuff, but the point of last would be something like your data is arranged by like date or something.
Yeah,
and like
yeah.
The last value is the most important one, so just keep only that one.
Yeah, something like that. I guess that would be the use case. Like imagine you have a transactional database and it's arranged kind of from kind of like sequentially from earliest to latest. Then yeah, you would want to join on the last maybe. I guess it kind of like implicitly it does almost like a summarize for you, where you don't have to do your summarize last kind of. You're just you're composing a data set by joining. And when they're multiple, where you find the key multiple times, you're taking the last instance of that.
Yeah, I mean, I think you can also envision that you care about the highest value or whatever, and it's sorted by something like you think you're
That's
most
true.
worried about, someone's
Yeah,
highest
you know how it's sorted,
something.
and you know whether you need first or last.
Yeah, I would want the sort to be like right before this join to be confident in that. Or
Exactly.
But,
exactly.
I have a question about this, Arthur. That
Sure.
I don't have my personal R open at the moment, so I'm relying on your knowledge. But I thought that when they released when they did the new dplyr release in January, February, or whatever, that this gave an error when you had multiple keys and didn't specify how they were joining, and then I thought they rolled that back.
Wasn't it a warning message?
No, I thought it was an error initially, and then they rolled it back to a warning. But I was because people are like, okay, the error is a bit much. Like we need to be. Thanks for the communication, but I could totally be wrong about that. I should open up the news right now.
I don't know that. I'm not sure, Rebecca. That
Okay,
that
you didn't run
would
into
be.
that.
I vaguely kind of remember that though. So I would
They definitely patched it. The double messages.
Maybe we can check in the documentation if this is the new feature. Multiple.
Yeah.
logs.
Okay. It's on the if you go to the news, it's the yeah. You're right. No, you're right.
Oh, I was in the right place. Okay.
Yeah, I was just looking at my own screen. Yeah,
It's 1.1.1.
Paragraph is he talks about it. Okay.
Oh, okay. Refining the multiple watch. Okay. Warning thrown by dplyrs joins. Okay. Let's see what that says.
So it's just
Warned when you perform the join where wrote.
Oh, okay. You're right. It was only ever a warning. You're right, Jack. Okay.
Yeah, there could have been a different error message that comes with a warning as well, though. I'm not sure.
I wish there were an option to actually have the error, have the warning. I mean, I can definitely understand where this would bother people particularly in like production environments, or where somehow you have something that's watching for warnings. But I feel like for interactive use, this could be helpful because it could flag situations where maybe the analyst doesn't know how things are going to join, and at least it tells you that things are joining in maybe a different way than you expect. Because I can tell you with I don't know if this is feature. Well, anyway, one thing, sorry, with Stata, for example, is that when you're merging, when you're joining, they use the word merge, but when you're joining two data frames in Stata, you actually have to specify how things join, right? Or rather the relationship. So is it a one-to-one? Is it a one-to-many, a many-to-one, a many-to-many? Whereas in R, you don't, at least for this, you don't have to.
Okay, so you're used to being very explicit. Yeah,
you have to be very explicit, and if things don't work in Stata, it errors, and just tells you that that it's the keys that you've selected do not uniquely identify observations in one of your data frames, yeah, and like given like how you're expecting to join. So I sort of felt like this warning was useful in the sense that it could flag, it could flag issues where you join two tables and imagine you're working with big-ish data, you may not notice these problems, right? It would be good, maybe good to know.
Are y'all familiar, this is slightly off topic, but with the tidylog package?
Not as familiar as I would like to be. I've seen that in passing, and I would very much like to join to
I
look
like
into that
it
one.
because it by default prints the sizes of like, oh, you just created a new variable with 10% NAs, which like, oh shucks, like my case win like didn't match as many things as I went to, or like the size of your data set rows on. Yeah, I love it, and I kind of just wish that dplyr would just adopt it, because I don't love dealing with conflicted and masking, even though it's all safe and whatever. I would just wish dplyr would just wrap this in, and being able to turn off options, dplyr verbose equals false or whatever, for people who don't want to see this everywhere. But I feel like it never hurts my brain like to just do that real quick and know what's going on.
Yeah, one of my colleagues has developed a package that kind of does something similar, where he's coming also from Stata, and he wants when there are joins, basically to kind of indicate like what's coming from where. So this idea of like having this one-to-many join, many-to-one, etc. Sorry, I'm just kind of pulling this up quickly, but it's a neat idea. It's a neat package.
Neat. All right.
Cool. All right, so multiple. Unmatched. So let's see if I can remember what I wanted to do with this one. So if I have my data frame 2, I've got this, and let me add to, I'll call df2 with widow, or maybe orphan, I'm not sure, maybe it should be more orphan. Anyway, I have an observation that whose key isn't matched in the other data frame, right? So what I could do, like the default is when I left join two data frames, I feel like this is maybe not the best example, but when I default when I join two data frames, the default is, what is this argument? Unmatched equals drop. So any observations from Y that aren't matched in X are dropped. This is probably a poor choice because this is a left join. And the alternative is here to have an error message, to have an error if you're just lets you know that there is something in Y that doesn't have a match in X. And it tells you, I guess, via Waldo where that occurs. So this is row number 5 of data frame with widow 2, or data frame 2 with widow. Yeah. So that's unmatched. This is coming, I guess, to the one-to-one, many-to-one thing, and I freely admit I didn't get very deep into this, but let me just kind of prepare a data frame here. So I'll have a data frame. I'll have a data frame that'll have a duplicate. So df dup. Whoops. df1 dup. Yeah. So I have now another. I guess a duplicate in the sense I have the same key twice, and then from the df2, if you'll recall, I've got this. So I'll remove one row. So I decided to use slice for this to try to kind of work my newly acquired slice muscles. So I guess I'm calling it deduplicated because I'm removing this row. Okay. So I can join these two. I can join these two together. Let's see. What am I doing here that's wrong? df2. This, ladies and gentlemen, is why it's good to review your notes before presenting.
The
No,
data
this is
frame
great.
name is different, I guess.
Yeah, let's see. Names, df2.
No, not name. I mean the name of the data frame in X.
Oh, an X. Okay. df1 dupe. So that's correct. Okay, df2.
So this is where you would expect an error though, right? There are two keys in.
Oh yeah. Okay, you're right. You're right, Rebecca. Yeah, that's making my point. So this is a relationship where I've got two keys. So yeah, I've got row 1 matches multiple rows in Y, and row 1 of Y matches multiple rows in X. And so it's basically asking me to, and this is a warning message. It's asking me to, yeah. So if you're expecting a many relationship, then better to set it to silence this warning. So by default, we don't specify. It's sort of like the analog, I guess you can say, of if you're joining without specifying keys, and dplyr basically sees that the same named columns exist in the two data frames and merges on those columns, or sorry, joins on those columns. dplyr will issue a warning, I think a warning, or at the very least a message that basically says, hey, we're joining on this. And so the idea here is that this might be something, I guess, is to call your attention to, like, if this is unexpected, just know that this is what's going on, and it's better to kind of, in this particular case, to kind of specify the relationship between the two data frames. In this case, a many-to-many relationship. So here I can do 1-to-1. So here I've got df1 and df2 deduped. So here each one of the keys occurs only once in each data frame, so I can have a 1-to-1 relationship. Here I've got df1, df2, and I have a 1-to-many relationship. So for each value of the key in X, I have one or more rows with the corresponding key. And then there are other ways you can specify this relationship. 1-to-many, 1-to-1, 1-to-many, many-to-one, and many-to-many. So this is very Stata-esque for me. Yeah. Any questions or reactions on this one? Now that I finally figured out what I was trying to do in my notes.
No, it's great. I think working through this is great.
It was a happy accident. Yeah. So then on marching forward, I guess, to nested joins. This was something that was very new to me. And I'll kind of narrate what's going on here. Whoops, sorry. Let me narrate what's going on here. So I'll come over here. I've got df nest1. So this is just a tibble with a column X, values 1, 2, 3. df nest2, which has some of those. So in X, it has some of those same keys, and then it has some values. So for 1, I have nothing. For 2, I have 1 row, and then for 3, I have 2 rows. So I mean, obviously, I could kind of join these two things with left join, inner join, those kinds of joins. But what if I wanted to nest them? If I wanted instead things to merge, the data frames to merge on keys, but basically have it produce kind of a data frame with a list column of data frames. So maybe it's easier to see the thing than to describe the thing. So if I nest it, what's interesting here is that it takes 1, 2, 3, joins on this column X right here, and then it creates a data frame, yes, which is expected, but a nested data frame. So a data frame that contains data frames. So here I have where I have 1, I have a tibble with 0 rows in 1 column because 1 didn't exist in both data frames. 2, row 2 right here, I have one row, a data frame of 1 row, because 2 existed only once in both data frames, or importantly, only once in the Y data frame. And then a tibble of, so for 3, I have a tibble of 2 rows because for the key value 3, I have two rows in the Y data frame. Kind of interesting. And if you wanted to unpack it, it would look kind of like this. So basically, this column right here, this column is it's a list of data frames. I'm not sure I've ever had use for this, but it's kind of cool.
No, I iterate over, you know, when I'm using per, sometimes there are probably things I've done where I could have also done this, and I don't know which is better, but I don't immediately see a very clear descriptive use case, but I can kind of see that it's neat that it exists. So thanks for cluing me into it.
Yeah, I'm in exactly the same camp as you, Rebecca. I'll continue to use per, but I still thought this is kind of neat.
This might help me like create the list sometimes of things.
Yeah.
Reading per, maybe. Wait a minute. I don't know. I'm not sure.
Yeah.
It's neat to know about. Thank you.
Oh yeah, that's true. That's true. If like basically you have data frames, if like somehow you got your data frames into the global environment, then you wanted to compose this thing, maybe, right? Instead of like, in my use case, I'll have like per where I'll maybe like open files and then somehow like create a data frame, like a data frame like this, where each kind of data frame in the list column is a data frame I've read from disk, let's say. Cool. So that's nested joins. Filtering joins. Yeah, for this one, I'll just kind of go to the documentation. I thought the documentation, I didn't have anything to add on top of the documentation. So, so these are the joins where, you know, so mutating joins, I've finally kind of understood, are so called because they basically add columns to the data frame, aka mutate, whereas filtering joins simply filter the observations as a function of which observations find themselves in each of the 2 data frames that you're joining. So, you know, semi-join and anti-join are your data frames here. Let's see, what was I, again, copy, our friend copy, and some of the other things that we've already seen. I'm not sure that I really had anything I wanted to show here, just that I didn't want to reproduce this Beatles example.
It's all the same arguments, isn't it? Like,
yeah, it's exactly the same arguments. Yeah, I mean, it's just, you know, when you have 2 data frames with the same keys, you can just kind of filter your data frame. So yeah, that's pretty much it.
So the one thing I feel like adding is just, this doesn't exist as far as I know it in base SQL. So you have to do like a where clause where something doesn't exist or something. And I have been known to mess that up. So, and I have managed to go a long time in R not knowing that these exist. So I need to start reaching for them because it's very easy to just get into the habit of working around it. But
so
like
my question for on that I'll ask on your behalf is whether this exists in dplyr.
I bet that they translated into the SQL code, but dplyr.
I mean, they do, right? Or if they do it, they do.
Yeah, but the question is,
sweet.
Yeah, they do. Yeah, where
awesome.
not exists. Yep.
Interesting.
No, cool for getting straight to the SQL code. That's helpful.
Exactly. I don't know SQL, but if I learn it, it'll probably be through the docs, the dplyr docs. Yeah. Okay, so that's pretty much it on filtering joins. Actually, I don't know. Were there any other things that people wanted to add or to ask on filtering joins?
No, I think, well, personally, I think pretty good. Like,
I mean, the one thing I kind of notice is I feel like some of the set operations could, well, if you have two data frames with exactly the same columns, then you could get by with set operations too. I'm not sure if one is more expensive than the other, but I've been known to use set operations on rare occasion instead of the filtering joins. Cross joins. Oh, sorry, go ahead.
Right, like for nearly anything, if you can use them. But I mean,
Sorry,
yeah,
say again.
you'd expect set operations to be faster, like you're saying you weren't sure if they're more expensive. You'd
Yeah.
expect them whenever you can use them to be faster, but
It seems
not.
reasonable, right? Cross joins. So this was actually very interesting for me. Yeah, I'll just read what's on the screen. So basically, cross joins just match each like key in X, where like each observation X with a certain key with each observation Y and a certain key, and then gives you a data frame that's kind of the cross between the two rows. And this was the interesting part I'd never thought about, but is really interesting. So since cross joins result in all possible matches between X and Y, they technically serve as the basis for all mutating joins, which can generally be thought of as cross joins followed by a filter. A more specialized procedure is used for better performance. So that's kind of like an interesting mental model to have, even if like on the implementation side, it's not what's being done. And maybe also if you wanted to do your own kind of join, perhaps, doing a cross join and then doing some operation that might be able to help you ultimately implement the join you have in mind.
So do you have code for this?
I do not actually. I think at this point I'd gotten lazy.
Oh, totally fine. Totally fine.
Let me see what there is in the docs, however, because I don't want to do this disservice.
Because to me, it looks very much like expand grid.
Yeah, exactly.
But expand grid is probably just 2 vectors, or maybe that's not true. I'm not sure. Expand grid can take.
Is it tidyr? Is that what it is?
So I mean, there's a
There's
base
crossing. There's crossing in
Oh, okay.
tidyr, right? Which is like essentially the same as expand grid.
Oh man, I feel like I should understand the difference between these.
But I'm wondering for these, if like the scope of if these functions in tidyr is kind of larger than it is with cross joins. So cross joins would, I guess you need to have a data table, right? It works on the class of data tables, whereas expand grid maybe works also on vectors and other stuff.
I don't know, but now I'm confused by crossing.
Yeah.
Where we'll get there.
I'll have to, I guess we'll come to this in future, but I'm kind of intrigued now. I hadn't thought about that until your remark, Rebecca, but yeah, maybe, I mean, I guess what I'll kind of keep in my mental model is that, cross joins kind of do like expand grid type stuff for data frames.
That's right. It's a different, wait, what? Do they have code down below?
Let's see.
Output.
They've got some examples.
Every row in X and every row in Y. Okay. Thank you.
Yep. No worries.
Wait, so I haven't really looked into this too much either. Like, what's it actually saying when it says, okay, John is the name in X, right, and he plays the guitar, and then the name in Y is Mick, John, and Paul. Who's sorry, who's Mick? I haven't even properly looked at this data set, I think. I don't, like, why John plays the guitar and Mick is in the Stones, but then John and John are the guitar and they're in the Beatles.
So I guess they're joining on plays, like on the instruments that they play, perhaps. Let's actually let's go to the console.
Is there?
So let me actually load dplyr so I can access the data frames. Whoops. And it's band. I say, what was this?
Yeah.
Band instruments, band members. Okay.
So there's no key. They're just doing all possible combinations of two things.
Oh, so it is. Okay.
Yeah, but I don't get why I don't, from their example, I can see like what's happening with the code or whatever. Like, why would you do this? Like, what does it mean?
Well, if you have like, I don't know why you do it, but I don't know. I think the idea of like, I want every combination of these things. I mean, I don't think, yeah, if you've got some small tables that describe like all kinds of bread that you sell, and then all kinds of bagels and all kinds of cream cheese, and then here are all the different kinds of things you can offer.
Yeah, but then I feel like for that you should just use crossing and like refer to the columns and the unique values or something in the columns of a date. Like, I guess we'll get onto that when we get to tidyr for crossing.
Maybe they're setting the stage for Mad Libs with our data sets, right? So you could like do you like kind of do cross join and then use glue. Yeah, and I don't know. I have no idea. I mean, I get the idea. Like the example maybe isn't the most helpful, but I get the idea. This is something I found. So moving on to join specifications, I felt like this was really, really interesting. And I wasn't aware of this. I believe this is a dplyr 1.x novelty. But so as we saw earlier, you can specify, you can specify your join, kind of like you're joining on columns when, joining on keys when keys are equal. But with the join by, you can actually do different things. You can have, so this is kind of like your rolling joins, for example, I guess. You can have, when keys are equal, when one key is greater or than equal to the other, when one key is greater than, less than, etc. So you can have these kind of you can join using like an expression, I guess you could say.
Yeah, there's stuff like, so you like, it's almost like not quite fuzzy matching, but like, I guess there's inequality stuff, right? So like, just join by the value that's closest to this, which is pretty cool. You'd have to be careful when you're using these. Like, I feel like you'd have to go really slowly and get some real test cases set up before you end up doing something that seems to make sense, but then like practically is dangerous or whatnot.
Yeah, I've never ever had a use case for this, at least so far. I don't know if it's for lack of inventiveness or just it's outside of my wheelhouse. But it's interesting that this exists.
Yeah, so when you first earlier when we were talking about the like matching the last or whatever, and I was thinking about if things are ordered by whatever, I use blood pressure as the example. I was thinking that maybe when we got here, that would be another way of getting to that same thing, but that's not the point. This is just dealing with the keys. And the other thing was dealing with non-keys, right? If you're looking at last match.
Although I guess you could, I mean, like coming to your blood pressure example, Rebecca, I mean, is like maybe you could have a thing be a key that's not like naturally a key. You could say like merge on cases where blood pressure is within a certain range.
Okay. Wow, there's so much detail here that I'm sure.
Yeah, exactly. And I wasn't planning to go down this I wasn't planning to go down this rabbit hole. I mean, if there's sufficient interest, we can try to parse this together, but it looks pretty dense. It sort of seems like it might be something better read solo than presented, but we'll see.
Yeah, because they're pretty cool. That like you said, the two, like some ranges, say if you know that like between 10 and 20 is like, say it's the weather and that's mild, and you just want to join, it's kind of like a case when in that case, I guess.
Yeah.
Do it directly in the join. Yeah, it does seem like it would be too dense to try to sit and figure out like on camera.
I mean, maybe we can kind of like go through the examples and hope that they're telling. So I guess they're just generating some arbitrary sales data with some IDs and sales dates. Then you have a data table of promotions. So I guess when promotions are run with some ID and then the date at which the promotion happened. So obviously you could kind of like match on match on dates, do a left join on dates. Maybe you could join on where the promo date happened before the sales date. So maybe if you're kind of looking to see if sales increased after a promotion occurred.
Yeah, I guess say if you were like joining different databases and stuff, and you had prices, like you might have the sale date and stuff in one, and then the promo range, and you might want to check, was that sale date in this promo range?
Yeah.
And if it was, you change the price or whatever, like.
Yeah, I think the date example is really helpful. That makes it seem somewhat intuitive.
Yeah.
We are
And then
kind
here
of
there's
using,
like a closest thing. Yeah. Oh, sorry. Go ahead, Shah.
yeah, we are kind of using dplyr filter that we are filtering in the joins, not like using filter before the joins.
Oh yeah, that's a good point. That's a good point. In a sense, it's kind of like that, I guess. Yeah. I do wonder too, like what the scope of this is, like in terms of classes. I presume it's just regular data frames. Not that I do anything with geospatial stuff, but I wonder if you can have spatial joins that allow for these kinds of like pseudo fuzziness in joins, I guess. It's like, let's say join 2 points if they're close by, and then you could define what close is. Or if like a point is within a set, like within a bounding box, like a geographical bounding box. Anyway, undoubtedly SF has something like that.
Yeah, they have their joins and ST joins or whatever in the SF package.
And it's using some of the stuff like, are they coming in vectors like between and stuff? Where were they from?
So they've got a between specification here. Guess it's overlapping joins between, within.
Yeah, I'm just thinking, where do these sit in the reference? Like, where's between? Okay, yeah, those are all in the vector functions, and we're going to look at those next week.
I mean, I wonder in this particular case whether, Jack, like whether the betweens are the same betweens, if that makes sense, or if it's kind of a between that's spiritually similar, but maybe not technically similar.
Yeah, but it's not like they're.
Because I don't see a link here for the betweens. I mean, I guess we'll see. You know, I guess Shah's gonna present, I think, on those.
Yeah, I just wondering, so is overlaps in there too? Or are they, okay, so what was, oh, sorry, overlaps. Where's overlaps even from? Like, where does that sit?
So this is just with the join by. So basically, if you do your joins, however you do your joins, then, or let's take, for example, like left join. This comes in with the by specification. So with by, you can have your, I guess what's traditional, I suppose, which is oddly at the bottom for simple joins of equality, and then they have this whole discussion about using the join by specification.
Yeah, sorry, so are these methods that are implemented separately for join by, like, or
you mean for between and things like that? Yeah, that's kind of the thing I'm honestly not sure about, because if you, not that this is, you know, smoking gun, but there's no link here, right? So I don't know if it's just like, if it's specified just within the join by specification, or if it's the same as the between with for the vectors. Don't know.
Yeah, because I'm looking, like, if I look for, say, like, look for the help of overlaps, then it only seems to appear in join by. Or like there's data table and stuff. But in terms of dplyr, it only seems to be inside join by, which makes me think it's probably an S3 method or something. Well, that's weird because join by isn't an object. Yeah, maybe it just doesn't say.
Definitely worth looking into. Because yeah, when I saw between, that piqued my curiosity too.
Is it they're neither in like unexported functions, like they're not in the triple dot namespace or anything.
Oh, interesting.
I guess that's maybe a case of actually going through the repo and seeing what they are. Yeah, it's really weird because there's like a list. Data table dplyr. Anyway, I mean, not to hijack it too much into this. I'm going to put that down as a to-do.
Yeah, no, that's definitely worth looking into, because I feel like this is new and opens up it, you know, whether it's new or just new to me, it opens up a lot of possibilities. Yeah, I guess maybe in the little time remaining, I guess I'll just look at this last little bit, which maybe Rebecca, since you have some SQL skills, maybe you can enlighten us, or at least me on, is this last little bit within the section where it's where basically you're like manipulating individual rows. So I think for most of these, I think when they are rather for functions that are effectively kind of like doing the same thing and as in SQL, they kind of show the SQL equivalent. Like, so rows insert is kind of like insert in SQL. Rows append is the same thing, but ignores keys.
And you know, the janitor package has like adorn totals and stuff. Is it like supposed to help you do this and stuff as well?
So for this one, it seems like let's see if they have some good examples here. So basically, it allows you, like, imagine you have a data frame, and then, you know, let's say you have a master data frame, and then you have some new observations that come. And so the problem is, how do you integrate those observations into your master data frame? So there are a few like kind of conceptual operations you could do, right? So you could insert them, but then you weren't here, like in SQL, you'd assume that the keys between X and Y don't overlap. So if you have basically, like, it's kind of like an append operation, right? You're appending new things, but you're not going to create duplicates in the keys. You want to ensure that there's uniqueness in the keys after the operation. Rows append is kind of a maybe more sloppy operation where you just kind of slap Y onto the bottom of X. So that's a way of like updating your table with new observations. And then there's an update. So these are kind of interesting too. And here, I guess I'm coming from a Stata perspective where Stata does some things. Let me see if I'll reread this. So basically, you'll update. Let's say you have a new record, or rather, you have a data frame with the same records, and you want to update the records with a corrected value and just overwrite entirely that row. That's rows update. Rows patch works similarly to row update, except that it only overwrites the values where the values in the master table are NA. So for example, let's say you have some missing information in your master table. You get a new complete record where the NAs are missing, and then or sorry, where the NAs have been filled in, then you can kind of like patch your master data table. And then this upsert, which either inserts or updates depending on whether the keys match. And then lastly, you could kind of delete rows with rows delete. Does this seem useful, Rebecca, for your cases?
So Rebecca asked a question in the chat.
Oh, sorry,
Yeah,
sorry.
and I gotta run to my next meeting, but I guess to me, the point of this is, well, I don't know. I will maybe remember to watch the last couple meetings as you've spent minutes. But my guess is the point is kind of more like just for consistency with SQL operations, right? Because I just feel like intuitively I would do different things if I was in tidyverse.
I think broadly speaking, yes, but I feel like there are also some operations that this opens up that don't exist in dplyr natively, at least in an easy way. So for example, with patch, I don't know if there's an operation where you can, let's say you have a data frame with certain values, but maybe some missing elements for certain columns, and then you have a data frame where those missing values have been filled in. I don't know that there's a way to kind of like join these two tables and in so doing overwrite the NAs with the updated values.
Yeah, I guess I would just do that, with some where statements and whatever. But
yeah, exactly.
I mean, it's neat to know that this exists. It's very neat to know that this exists.
Yeah.
But is there something else, like, say if you bind rows, then you can duplicate the keys easily, whereas this throws an error if you start duplicating keys?
Yeah, for rows insert, yeah.
So that was, because I was thinking the same thing, like, why is this different to bind rows or rbind? But is it just like it's safer?
For that example, yeah, I think so. And maybe also like, maybe I don't know if this is the case, but perhaps this exists also to offer a bridge between dplyr and SQL. So maybe like by creating this function in dplyr, they've kind of implemented like a version of this within dbplyr that performs a SQL operation.
Mm-hmm. Yeah, because it's always been difficult to add rows like to a data frame or something. I guess the argument is that you don't normally want to be adding rows in R, like you start botching your results and stuff. But yeah, maybe this is another one worth playing with as well, like the cross joins.
Yeah, and probably also the examples are nice, but I hadn't looked at them beforehand, and we kind of run short on time.
Yeah, cool. Well, thanks again. It turned out to be quite like an ordeal for you to do both of these data frames. There's a lot in there.
Yeah,
it's a nice job. That gives you a rest after, probably. Like,
it does, yeah.
Quite wanted. And then Shah, you're going to take us through the vector functions next week.
Yeah.
Looking at them, there's lots of functions that are kind of like lesser known in here, but really useful. I don't know if this is a 1 week job or if this is more. Maybe I don't see how you get on with it. And if you get the feeling this is like too much stuff to do in 1 week, just let us know and we can plan to split it over two, and either you take both weeks or you pass it on if you don't want to do both. So don't feel like you have to like rush through anything, because I think some of this stuff, like the consecutive ID, solves quite a few nice things. There's quite a few nice things in here, like case matches.
Yeah, I will like come up with examples and for every case, and if I can do it in 1 week, that's good. Otherwise, we can expand it to the next week.
Yeah, cool. And I just know stuff like lag and lead, which you don't need as much now. You've got consecutive ID. But I mean, anyway, let's see how you get on. And if it is 1 week next week, then maybe we do like programming with dplyr the following week. And then if not, I think we're done. Like we go on to Perl or something.
Yeah, finally.
Yeah. Cool. Well, cheers, guys. I'll see you next week.
See you.
See you then. Bye-bye.